So the first thing, the question, anyone, because we are somewhere on the edge of research, we are a research project, we do also compliance, and there's this OC compliance today. So anyone has any idea what security certifications are? Okay, that's great, amazing. I didn't expect, that many people, to be. So yeah, what we are going to talk about today, there are, two major, or now kind of like a free, interesting, to see myself from the speaker. So we will talk about common criteria. It's an international standard, the ISO 15408, and I will show you how the certificate looks like later. We also now have the EUCC. That's kind of like an implementation of common criteria framework in the EU. You probably heard a lot, about CRA during this conference. So EUCC could actually be used as one of these, evidence for CRA for the critical products. So that's quite an important thing these days. And then we are going to show you a little bit about, FIPS 140-2 and 140-3. This is initially a North American standard. Now it's international standard also under, ISO standardization. So I will, quickly, introduce you to what these, certifications are, how these certification works. So you will see, why we are doing this project, and Vashek will like to, tell you more about the actual implementation. So, common criteria EUCC. You have so-called, target of evaluation. That's basically that, part of your product is going to be evaluated later in the process. There are a few things. The security functional requirements, but basically, defines, what your product implements from, security standpoint, and then, it's evaluated. The evaluation of the target of evaluation is the reality check between, what's in the security target, that's a document that contains these, SFRs, and what's in your product. And then we have something that's called, protection profile. So the protection profile is more like a catalog library of these, SFRs. That's a template used. So I will maybe, go now to FIPS. So for FIPS 140-2, 140-3, one note, 140-2 expires this September. So now it's only, -3. It's the cryptographic modules validation program. It contains, algorithm validation, module validation, and entropy validation. So we receive, 3 certificates for different things. There is like this, limited set of approved algorithms and parameters like MD5 and other stuff, and this program is governed by CAVP and CMVP. People, connected with the NIST, the US standardization organizations. We have various validation scenarios. So I will, quickly show you how these certificates looks like. Yeah. So no, I can't see it. Okay, I wanted to show you quickly how the certificate looks like.
Kill the presentation completely.
Kill it for me. Okay, so this is, for example, one of the certificates. This is actually EUCC certificate. There are, these, award ceremonies. You can, go and get this certificate on paper, but we usually don't do it. So this is how the CC certificate looks like. And where is it? I made a mistake. Yeah. And this is, how the FIPS 140-3 certificate looks like for the Red Hat Enterprise Linux 9 openssl FIPS provider. You have all the information on this page. I can't, do it now. Yeah, I will go back to the presentation. That's the easiest way. Yeah. So you see this, and now the security target, one of these, documents that contains everything I told you about. You see, it's a very, very long document. So I will go back to the presentation. Demo time. So don't do demos. Okay, and now there are some challenges in security certifications. So one of the biggest issues is lack of transparency. These things are non-transparent. These are PDFs somewhere on internet. You need to find, you need to look up for these certificates. Super expensive things, especially for smaller vendors. It's something that if you want to achieve it, it's expensive from your time, resources, and money, and also it's extremely slow. Like the current queue for FIPS certificates, and we are talking about security certifications, is up to 2 years. So basically, you have like 2 years old openssl library that's certified, and then the one with the stamp is the secure one. No, it's definitely not secure one. So we have this project to add more transparency, to make certifications cheaper and faster in the end. So, Vashek?
Okay, and let me tell you now part of the story why we researchers at Masaryk University decided to care about going through thousands of security certification documents. We discovered one particular vulnerability that was about 9 years back that impacted passports in several countries, IDs in several countries like Slovakia, Estonia. Few countries did not launch or had to cancel their e-health card schemes like Spain and Austria, if I don't remember. And nearly 2 billion devices have been impacted. Very likely your TPMs, Trusted Platform Modules in your computers, as well as many, many others. And we were wondering then about one question that we originally believed was a very simple question. And as you know, simple questions usually have complicated answers. And that question was, okay, we discovered this one particular problem with cryptographic library in one particular chip. How many devices actually get impacted that were certified under the common criteria standard? To give you an idea how many products we are talking about, common criteria is a scheme that is in the existence for over a quarter of a century. Over a quarter of a century, and about 6,600 products got certified. When the scheme started, the certificates basically were lasting forever. And then finally somebody decided that typically the products do not keep their security status forever. Vulnerabilities get discovered. So the compromise was made, a certified product, unless some particular problem is found, will be in validity for 5 years. So you see 2 columns in this table, and one carries the number of active certificates, one carries the number of archived certificates. Once a certificate becomes archived, you still actually have to pay attention to it, and you will shortly understand why. And note that for some categories of products, you have dozens of them. For some, you have just single units. And for others, you basically take 1/4 or well over a quarter, nearly a third of the ecosystem. And that's in particular smart cards here and integrated circuits. For these, you have like 2,200 of these products being certified. These are the beasts you carry in your banking cards, some of them in your phones. And the providers of your banking cards demand the security evaluation under the common criteria scheme. So we are talking of thousands of certified products. Each of is carrying a certificate, as you have seen, many of them carrying additional certification documents. On top of that, the originally North American scheme, FIPS 140, 2 or 3, carries well over 5,000 certified products, cryptographic modules. About 1,000 of these certificates are still valid, non-archived. So we are talking altogether of about 12,000 certified products and about 30, maybe 25,000 certification documents. Certification documents get published and get issued by individual vendors, countries, and vendors and countries have different cultures of producing documents. For many producers, or for some producers of some certificates, even the complicated function Ctrl-C and Ctrl-V seems to be beyond the level of automation that was achieved, and not even interlinking of index numbers between the certificates is carried correctly. So if you get a product that is certified, that's our yellow beast here, was certified under this certificate number by the German BSI, and then you know that if you discover a particular vulnerability, it impacts this particular product. Then if you go and if you know where to look, you will discover that this particular chip microcontroller is actually used in at least 3 other products that got certified under the French scheme by ANSI. And this way you can carry forward, because one product often uses another for building up the security solution. And that leads us to investigation of references. So before I come to the definition of references and what they allow us to discover, let me provide you with a nutshell what effectively we do. We suck data. We suck data from the Common Criteria portal, and we suck similar data from of the US provenience. We put this data through some cleaning processes. To a certain extent, we still use regular expressions. Now we are transferring more towards the LLMs. And eventually we get to a tool that we are talking about today here, and that's a tool called sec-certs. Sec-certs is provided through several interfaces. You can use sec-certs through the web interface and do your searches there. Or if you are a large corporation or national agency, you may not want the crazy researchers at Masaryk University to know what queries you are filing through sec-certs, so you can install it on premise and you can run it on premise. Sec-certs is provided as open source, obviously, and you can link our data that we suck from this portal together with your proprietary database if you are sharing one with your compatriots in some undertakings. We link it also together with vulnerability databases, so that a discovery for one's particular infrastructure, what products you should worry about if vulnerabilities against these get discovered, is made much easier using sec-certs. So we are building effectively, or as one of the important activities within sec-certs, we are building a reference graph. Imagine this simplified certification documents that says that you certify certain smart card. This certification is based on a recertification of an older smart card and using its specific evaluation results. And it also is using a particular integrated circuit that was certified in another certification process. So you have 2 kinds of dependencies: predecessor dependency or component reuse dependency. You should not worry about these dependencies anymore. Let me try to impress you with this particular graph that will come in a minute. And the graph displays the dependencies between the thousands of certified products. Each device, each beast certified under common criteria is a vertex for us. Some of these will be isolated. That product does not depend on any other products in terms of the dependencies defined before. Others, as you will see in a moment, create clusters. Our graph is of a reasonable size, 6,000 vertices and 3,000 edges. You get something like this. For those of you who sit closer, you can even see small icons. These icons are displaying the type of the products according to the table that you have seen a few slides back, whether it's a smart card, operating system, biometric authentication device, or something different. The products that you see here are not interdependent and do not create clusters, but you can see some clusters in certain locations. Where the icon is green, it's an active certificate. Where the icon is yellow, it's an archived certificate. And as you can see, for example, here, you often have clusters of dependencies between active and archived certificates. So what do we do using this graph? we do a lot of, or we have a lot of fun with this stuff. What we discovered, 3 top things that we believe that are the top things that we discovered. 10 products, 10 out of the 6,600 certified products are impacting 16% smart cards. If you recall from the table, smart cards create about 1/3 of the ecosystem. I made this calculation easier for you. We are talking of 220 plus smart cards are dependent on top 10 integrated circuits or microcontrollers. If any of them fails, a vulnerability gets discovered. You can count on dozens of products with the high security certification by common criteria getting impacted. When we did this work for our ROCA vulnerability, we discovered over 50 other products like national ID cards, smart cards, and others being vulnerable to this particular flaw in cryptographic key generation. One positive finding, higher reach, that is higher level of clustering, more dependencies on a particular certified product, is positively correlated with this level of certification being higher, being done with a higher level of diligence. So this is one of the positive findings that we made in the process.
Okay, so in the nutshell, we have developed a pipeline for automated processing of common criteria and FIPS certificates, plus, the vulnerability database, as Vashek said. We do the dependencies between the certificates. We have the continuous insights into certification ecosystem. So if to follow, closely what's going on, you can do it through sec-certs. And of course, you could see that we added more transparency into the ecosystem because previously it was basically impossible, to do this, search for affected products through these, certification dependencies. The biggest, problem in this area is like these, documents were written by humans for humans. So the parsing, extracting the information, it takes some time. It's regex based and with LLMs, but you will now have the API access to everything, and you don't have to do anything, or you just can install it or use the web interface. Okay, so what are the use cases? If you are a user. Okay, so if you are a user, you can, for example, see, what security claims are made for products. You can, monitor certificates you are interested in. Let's say if you are waiting for some certificate to appear on the list, I told you it can take, several years, to see the certificates, and you can, do watching the certification pages every day. One interesting part of the project is there is like this, heuristics to map CVEs to certified products. That was actually one of the papers. If the certified products are more secure than non-certified products, I recommend you to read that one, and other analysis. Then for vendors, let's say like me, what's important? I want to see what our competition is doing. I can't do like morning tea and go to the common criteria portal, FIPS portal, and see if our competition is doing something suspicious. We should probably follow too. So now I have a way how to get some business data out of the security project that it originated in security team. And for example, one example would be, let's say if there is a new platform architecture, I don't know, AR64, the ARM platform, I will see that my competition is doing something that I'm not doing, and I will, can follow them. So for certification bodies, they sometimes, don't like us because we bring more transparency, and they believe it's not a good idea. We believe it's a good idea. So, but they can, let's say, watch the performance of the ecosystem, what's going on. They can see if it's something suspicious coming from other, certifications bodies, because there is some, kind of mutual recognition between national common criteria schemes. and so on. And yeah, certification laboratories. So you probably, as you know, most people know what common criteria and FIPS is. There are so-called certifications labs, the companies that provides the evaluation activities. They can, for example, see what other labs are doing, what are the trends. If there is a new protection profile, that means, okay, we probably need more knowledge because, I don't know, smart cars are getting more traction. Actually, that's a bad example now. So yeah, one of the things. Then for the government agencies, as Vashek said, you can install it on-prem, and then you can enrich the data, whatever you need, and then use it as like one tool for everything. Okay, and general public, yes. Go to sec-certs.org, see what we can do, and yeah. So one of the case studies, so I will now change my hat from Red Hat to the openssl hat, because I'm also a member of the openssl Business Advisory Committee, and that's open source project, and we can see can we get some business data for the openssl project, like is openssl still prevalent, how much, what vendors may use openssl, because there's the openssl corporation that basically sells services like subscription to openssl, and for them it could be interesting question like, if are there any vendors we can come to and offer them our services? So that's one of the use cases. And what are the competitors? So yes, openssl is still pretty much dominant in this area. It's like almost 17% of common criteria, 16% of FIPS 140. And you can see other libraries there. Also, the very famous CVE Heartbleed that basically created a lot of forks out of openssl. So you can see that some of these forks might be getting more traction over time, and it creates some fragmentation in the ecosystem. So a very good data for openssl. Hey, do something about this. Or the whole community of crypto libraries. We don't need 100 different forks of crypto libraries, but we need one proper crypto library. So the data are very clear that you can see the boring SSL and other libraries getting some traction. So yeah, openssl is dominant cryptography library in the ecosystem, and you can use sec-certs for these data insights. So it's not only for security research, but also you can get some interesting business insights from these originally security data. And yes, one thing, this is all information that's coming from over 10K unstructured documents that are processed. Something that's impossible or was impossible before. So yes, use sec-certs.
So you can use sec-certs to go through common criteria certified products and associated certification documents. You can use it for FIPS 140, and you can use it for the new European EUCC scheme. Here you have a URL and QR code for the sec-certs beast itself. If you care about some of the findings we have done in the past years, in the right-hand side you have 2 scientific papers published in the Computers and Security journal. And actually, sec-certs was made possible using Cybersecurity Excellence Hub between South Moravia and Estonia. Sec-certs actually will be carried on through, and we will be testing it with devoted industrial partners, inclusive of Red Hat, in the forthcoming 3 years in the CCAT project, where actually 3 other security tools, open source tools, will be provided, and I will share a QR code for that project in a minute. And sec-certs started in our undertaking we have done in the cybersecurity for Europe, where the original idea, let's try to do something with this mess of certification document, was originally conceived. Here you have the link to the current project CCAT, where we are providing 4 technological tools targeting different levels of the technology stack, one for FPGA security, one for TLS security, one for investigation of smart cards, trusted platform modules, and other security beasts, inclusive of cryptographic libraries, and one of them is the sec-certs we shared with you. So many thanks for your attention, and we'll be ready to answer questions. Thank you. Oh, and we also have got stickers, so if you are interested in stickers and you don't have enough on your laptops, come forward and grab some.
Great. So do you have a question? Yes. Do we have questions?
Hi, thank you for your talk. It was pretty interesting. Just wondering, the graph that you showed, how do you calculate the distances between the nodes? Because there were some on the right.
The distances technically are not important. Important
Okay.
is where the products cluster. That is, there is an edge between the two products. That is what is important, not the distances.
Oh, okay.
It's a matter of visualization,
Yeah.
and now we are trying different techniques for displaying it, because what you effectively want is to have the graph at your hands and be able to click and see how many other products depend on this beast.
All right, thank you.
Thank you.
Do we have other questions? If not, why this is not an Eclipse project?
Who knows? Maybe in the future.
Okay. And another question is how much time it requires the computation of this, so it's immediate. If I'm asking?
No, it's not immediate, but it's. I mean, the searches and things are done on processed data. We basically scrape the data a few times a week. We provide new snapshots. We do the cleaning of the data so that the searches are significantly faster. A typical search from a typical connection will take you single seconds.
Okay. Okay, that's okay. So we are waiting for you in Eclipse Foundation. And we can, I think, if you want to say.
I wanted to say we are looking for contributors, so we can work together.
Oh yeah,
Yes.
if any of the tools of CCAD, whether and TLS scanner is one very particular thing that is of interest to many people, I believe, catches your attention, then reach out to me, because within the CCAD project, we will be involving also non-consortium partners into the testing, and you can influence what the tools will do for the money provided for this applied research. So reach
Okay.
out to me
This
if
is
any
a
of the
good
tools is
information.
interesting. Thanks.
Yes, this is a good information. Thank you.